Welcome to Measurement Part 6, Specific Gravity. This is a topic that's very relevant to allied health careers, so let's take a moment and see what it's all about. Let's get started. Okay, now I'm a unit lover, and hopefully you're starting to appreciate units too. Specific gravity was designed by people that don't like units. Oops, don't like units. Why anyone doesn't like units is beyond me, but I understand. Okay, so then what exactly is specific gravity? All right, well, we'll use SG to abbreviate it. And so mathematically, right, is an equal sign, right? So it's the density of a substance relative to the density of water. All right, so whatever the density of the substance is, X grams per mil, and then fortunately the density of water is 1 gram per mil for our purposes. And so then what do we see? What happens to the units? All the units cancel. So we're just simply left with the value of X. All right, so this is a unitless measurement. So why do we care about specific gravity? Well, it's used in two places that I know about. One is diagnostically in medicine for urine, and it's also used in the wine industry. And interestingly enough, it's kind of used for the same reason. Basically, it's a way to look at sugar in solution. Okay, when we have sugar in solution, the density increases. Okay, and so quite naturally, the specific gravity would also increase. Okay, so in the wine industry, it's really looking at fermentation. Grape juice has a lot of sugar in it, and then as it ferments into wine, the sugar goes away, so the specific gravity goes down. In the medical field, we look at specific gravity. It can give us indications about a person's health. All right, so when people are on diuretics, what do you think would happen to the specific gravity, right? Diuretics cause us to pee. If we're peeing a lot more, our pee is dilute, and the specific gravity goes down. People, though, for example, with diabetes mellitus, right? What do we know? We talk about the blood sugar, right? So because people with diabetes mellitus aren't able to assimilate the sugar that they've consumed, it's sitting in their fluids, and so that raises the specific gravity. Okay, so a couple examples of why we care about specific gravity, and then here is the tool. It's a bulb, and it has marks, and don't let this decimal fool you. The ones I've seen don't even have the decimal, so not only are there no units, but there's no decimals. But we know we're measuring an aqueous solution, and so we can see here that we let the device drop down, the hydrometer. We let it drop into the water. We usually use a spinning motion to release air bubbles. And then we look at where the liquid, the meniscus of the liquid hits our hydrometer. And then would be right there. And then that would be our value, right? So as shown already here, if we were measuring the specific gravity of this solution, the meniscus is hitting the scale at 1.140. So that would be the result that we would read for this solution. Okay, so not a lot to specific gravity. That pretty much wraps it up. But for the sake of completion, I wanted you to hear about it and know what it's about and some context for how it's used.